Welcome back, everyone. This week we are going to talk about slope and rate of change. So take a few minutes to read through what's on this first page so that you can understand what it is we are trying to accomplish this week. The first thing we want to talk about is finding slope between 2 points. You probably remember from intermediate algebra that we did this quite a bit, and we used the formula that you can see here in the blue box where it says slope is equal to the letter m, which is part of our slope-intercept form equation, y equals mx plus b. And the slope is actually the change in y over the change in x. So those two little triangles represent the word change. So that stands for change in y over change in x, which means the change in y is how much we go up or down, and then the change in x is how much we always go to the right. And you can see that in order to find that change in y over change in x, we simply just take 2 points and we subtract the y values on top, and we subtract the x values on the bottom. And the order, sometimes people get confused by the order and they think they have to go in a particular order. You don't have to go in any particular order. We tend to always do the second point first and the first point second, but you can flip that around as long as you flip both of them around. You don't want to flip just the y values around or the x values around, because then you'll have a sign difference on your slope. Okay, so here we have an example. We have the points 2, -6, and -8, -4. And what we want to do is just simply find the slope between those 2 points. So we are going to say that the first thing we want to do actually is identify the x1, y1, x2, y2. So for the first point, we can call that x1 and y1. And the second one we can call x2, y2. Now, like I said before, you can flip those around. You could call the first one x2, y2, and the second one x1, y1. It doesn't matter. You're going to get the same answer. So then we're going to go ahead and find the slope. So we're going to say m equals, and we're going to subtract the y values on top. So we have -4 minus -6 over -8 minus 2. Now, this example contains just about everything that you're going to encounter as you find the slope. So immediately we have subtracting a negative number. So if we subtract a negative, we remember that becomes addition. So we have -4 plus 6 over -10, because -8 minus 2 is -10. And then when we add -4 and 6 together, we end up with 2 over -10. And then a really important thing with slopes, and that it says in the green box down below, always simplify your slopes. So in this case, they're both even numbers, so we can divide both of them by 2. So when we divide both of them by 2, we end up with 1 over -5, but we don't like to just call that bottom number -5. So if one number is negative, it makes the whole fraction negative. So I'm going to put the negative sign out front, and I'm going to say it's -1/5. Okay, so the slope of a line that goes through those 2 points is -1/5. Okay, so one thing we need to be able to do is find the slope between 2 points. The second thing we need to be able to do is just identify the slope. And when I say identify the slope, what I mean is be able to look at an equation and know what the slope is right away. And the easiest way to identify a slope is if the equation is in slope-intercept form, or y equals mx plus b, because all you have to do is look for the m, and that's your slope. So in these first two, all we have to do is identify the m, and the m is always the number that is right next to or touching the x. So in this case, we have a slope of 4/3 in the first equation, and we have a slope of -2 in the second equation. Okay, so it's as simple as just saying my slope in the first one is m is equal to 4/3, and in the second one, m is equal to -2. Okay, the second way we can do this is if the equation is not in y equals mx plus b form, and if it's in standard form. And standard form is always the x term plus or minus the y term is equal to the c term. So you can see that here it's ax plus by equals c. And when we have an equation in standard form, we could take the time to solve the equation for y. and turn it into y equals mx plus b, but that's a lot of extra effort. If you can just remember that the slope is the opposite of a divided by b, then you can figure out the slope pretty quickly. So in this case, the thing we have to be able to do is just identify that we have our a here and we have our b here, and we just take the opposite of a, or the opposite of 5, and divide it by 3. So our slope is just -5 over 3. And the whole point, or the whole reason that is true, is because if we were to solve this for y, we need to subtract 5x from both sides, which turns 5 into the opposite, -5. And then we would divide by 3 to get rid of the 3 next to the y. So that's why we end up dividing the -5 by 3. Okay, in the second one, same thing. So we have, whoops, I don't want to use the pen. I'll use the highlighter. So we have a 6. And in this case, we want to be really careful because a lot of times people will just highlight that 4, but we need to remember that if it's minus 4y, the minus sign goes with the 4. So it's a -4. So what we're going to have is we're going to have a slope that is the opposite of 6 divided by -4. And since both of these are negative, it becomes positive. And then since both of these are even, we can divide them both by 2, so it becomes positive 3 over 2. So our slope in this case is 3 over 2. Okay, there are a couple of special cases that we want to watch out for when we're finding the slope. And here are the two of them right in front of you. X equals 8, y equals -11. Anytime we have x equals a number, y equals a number, there is a unique type of slope for each one of those equations. And the simplest way to see what that is to simply graph the equation. So I'm just going to draw two graphs here, and then I'm going to graph the equation. So if we remember, if we have x equals 8, we just go find 8 on the graph, and then x is always 8. So it doesn't matter what y value we pick, x is always 8. So that means that we're going to have a vertical line here. Okay, and when we have y equals -11, we do the same thing, except now we're going to find a -11 on the y-axis. And this is telling us that y is always -11. So no matter what the x value is, I'm going to have -11. So I just draw a horizontal line at y equals -11. And now we can kind of see my graph for -11 isn't the straightest in the world, but that's okay. What we can see is we can start there and we can notice that that line is horizontal. And horizontal means that it's not going up or down. And if it's not going up or down, that means that our slope is 0. So for any time we see a y equals equation, we know that the slope is going to be 0. And the reason that it's 0 is if we think about slope as change in y over change in x, we'll notice that the change in y here is 0 because it's not going up or down. So we have 0 divided by the change in x. Well, 0 divided by anything is just 0. So that's why this equation has a slope of 0. Now, in the other one, it's a little bit more confusing. It's a little bit harder to understand. But if we look at that same idea of change in y over change in x, in this case, the x is always 8. So that means the change in x is 0. So we have the change in y, and it doesn't matter what the change in y is really, but the change in x is 0. And in math, when we have a fraction, when we have 0 on the bottom, we can't do that. So since we can't divide by 0, what we have to say is that the slope of this equation is undefined. All right, so these are two special cases that you want to look out for, and it should be something that we just kind of memorize over time, and we see it and we say, anytime I see an x equals, I know immediately it's undefined, and a y equals, I know the slope is 0. All right, a couple of more things that we need to talk about. We need to talk about the slope of parallel and perpendicular lines, and they each have a unique relationship. And parallel is the simplest one because if you look at this example graph here, you'll notice that we have a green line and we have a blue line, and those two lines are parallel because they stay the same distance apart and they never cross. And you'll notice with the red little triangle on each one that the slope is the same. So we have a slope of 5 over 2 because the change in y is 5, the change in x is 2, so our slope is 5 over 2. And you'll notice in the two equations, in the green one, we have y equals 5 over 2x plus 7. And then in the blue one, we have y equals 5 over 2x minus 3. So when we have parallel lines, what we need to notice is that they have the same slope. So anytime we're asked to find the slope of a parallel line, we would just write the same slope that we see in the equation that we're given. Now, parallel lines are quite simple because the slope is the same, but perpendicular lines are a little bit more challenging because the slopes of perpendicular lines are called opposite reciprocals. And that's because perpendicular lines intersect at a 90-degree angle. And if you look at this graph here, you can see the green line has a positive slope. The blue line has a negative slope, so that's where the opposite part of reciprocals comes from. And then the fact that they intersect at a 90-degree angle means that their slopes are going to be reciprocals. So whatever the change in y is going to become the change in x, and whatever the change in x is going to become the change in y. So the simpler way to think about it is an opposite reciprocal is just a fraction that is flipped over and the sign is changed to the opposite sign. So what I mean by that is if it is a negative number, it becomes positive. If it's a positive number, it becomes negative. Okay, so you can see in this example, we have y equals 4/3 x plus 5, and y equals negative 3/4 x minus 1. So those two slopes are opposite reciprocals because they are flipped over and one has the opposite sign. Okay, in the helpful hint box in the bottom, I want you to notice that because we have a couple of special cases that we're going to run into when we're dealing with opposite reciprocals. And one of them is if we have a slope of 1. The opposite reciprocal of 1 is just -1. And that might seem a little odd, but the way we need to think about it is 1 is actually 1 over 1. And so when we flip that over, it's still 1 over 1. And we just have to make it negative then. So that's why it becomes -1. Okay, and similarly, if we have an integer like 4, 5, 6, 7, 8, 9, 10, or even negative numbers, -5, -20, it's a whole number or an integer, but same thing, we can put it over 1, and when we flip it over, in this case, the 4 becomes 1/4, and we make the sign the opposite, so it's -1/4. Okay, so any whole number can be written as a fraction over 1, and that's how we can turn it into something that we can flip over. Okay, let's look at some examples. So in this case, it says we want to find the slope of a parallel and a perpendicular line. So we're just going to find two different slopes, one for a parallel line, and that one's going to be the quickest and most simplest because it's exactly the same. So we know that the slope of a parallel line in this case is just going to be -2 because we have y equals -2x minus 9. Now, the slope of the perpendicular line, though, is a little bit more challenging because we have to think a little bit more. And what we have to say is if we have a slope of -2, we can remember that that's -2 over 1, but our slope of our perpendicular line is going to be that opposite reciprocal. So we need to flip it over, and we need to make it the opposite sign. So in this case, it becomes positive. So the slope of a perpendicular line is 1/2. All right, in the second example is not quite as simple. So if we think about this one, it's in standard form. And since it's in standard form, we can't see the slope right away. But what we can do is we can remember that the slope of a line in standard form is the opposite of a over b. And a in this case is 6, so we can identify that 6. And b is the 4. It's positive, so I didn't highlight that positive sign. So our slope of our equation here is negative 6 over 4. But again, we want to always simplify our slope, so this actually becomes negative 3 over 2. And I wrote the negative sign with the 3. We like to write it as the whole fraction as negative, so it's negative 3 over 2. Okay, so this is the slope of our equation that we're starting with. So again, parallel is pretty simple. All we have to do is write the same slope down. So the slope in this case of a parallel line is negative 3 over 2. But a perpendicular line, we're going to take the opposite reciprocal. So we're going to flip that slope over, and we're going to change the sign. So since it's negative 3 over 2, we know our answer is going to be positive. And instead of being 3 over 2, it's going to be a slope of 2 over 3.